Okay, so day 4, we're looking at systems of equations. Okay, so this is our first problem. And basically what we're looking for is, what is the value of this? So I need to find what A equals, what B equals, what C equals, and then I can plug those values in right here, here, and here, and see what I get as an answer. Okay, so let me show you how to efficiently do this. So follow along with me with the calculator, because this is a calculator question. Okay? So like I said, I'm going to take a quick picture with my phone, the equation, so that I can change to a different screen and actually talk you through this of what we're going to do. So let's go through and find the screen together. And from here, go ahead with me, press 1 for a new document, and press 1 to add a calculator page. Some of you might use the scratch pad, but I'm trying to help you use documents because they're a lot more efficient and easier to work with, of things that I want to show you. And here we go. We're going to now find what those ABC values are. So follow me. Menu, 3 for algebra, 7 for solving systems of equations, and 1 for solving the system of equations. Guess what number we're going to put here? 3. So we have 3 equations. We'll press enter, and it will immediately go to X, Y, and Z. Now I know I have over here 3 letters. I have A, B, and C. But if you remember in the original equation, let me show you something in the original equation that's very, very important. So right here I have A, B, C, and I also have D in there. Okay? So with that being said, how many variables am I really going to look for? 4. So let's come over here and put this into our calculator first. Let's go back to it. Let me go back right here. And from here, we're not going to have 3 variables. We're actually going to have 4 variables. Okay, so menu, delete to clear that. Oops, not menu. Control clear to clear that. So the blue button and delete. Okay, let's try this again. So menu, 3 for algebra, 7 for systems of equations, 1 for the systems of equations. And now, you know what, I'm going to see if it will do this, because this is something a little bit different than what I'm used to. I want to put 3 for 3 equations, and then right here, the variables it defaults to X, Y, Z. I'm going to see if it will do 4 variables. A, comma, B, comma, C, comma, D. Yeah, ooh, it did. Okay, so there you go. I thought you had to do 4 equations, but you don't. So it will solve all 4 for you with 3 equations. You see how we did that together? Okay, here we go. So now we're going to type it in just like we see it on our paper. 3a minus 7b is equal to, and the equals button is right here underneath control. And then we're going to put 4d minus 9, and then down arrow, negative 4c plus 10a is equal to 6b plus 7. And then negative, and this negative is right here near enter, so don't press the subtract key, but press the negative key. Negative 2a plus 3c minus 4d is equal to 10. And when you press enter, it gives, and that's what I was afraid of, it doesn't give all of the equations as we're needing it to give. Okay? So this one we do have to use 4 variables. Okay, so let me look at this real quick, because this is a abnormal problem. Okay, so the glitch here with all these C's are because if I do have 4 variables, I do need 4 equations, okay? And to get the 4 equations, I need to, from the equations given to me, I need to add them up, basically creating a 4th equation, okay? So real quick, if we were to write these out like A, B, C, D, and the number, the first one I have is 3a minus 7b. There's no c, so I can put 0c, and I'm subtracting the 4 over. I can leave the negative 9 on the right side of the equal sign. And think of the equal sign as just the line.
Is this Gaussian elimination?
It is, but we're going to do it with the calculator.
Okay.
So
I'm good at the TI-84s of this.
Okay, so 3a minus 7b plus 0c minus 4d is equal to negative 9. Our second equation is negative, it's 10a. Moving this across to the left will be a negative 6b. I'm going to be subtracting 4c. And I have 0d. And then I still have 7 on the right. Okay? Again, we're lining up all of our variables in correct columns. So the a would be negative 2a. We have plus 0b. And we have plus 3c minus 4d is equal to 10. And then like we saw, adding these all up together can give us a fourth equation that we need. Okay? So if I add all of these together simply by going straight down, I can see what I would get. So I get 13 minus 2 is 11a. You see what I'm doing? And then I have negative 13b. And then I have negative 4 plus 3 is a negative 1c. And then the 4's cancel out, right? So I have plus 0d is equal to what? Negative 8 or positive 8. We good? So negative 2 plus a 10 gives me 8. So now what I'm going to do is, just like I was thinking that you do need 4 equations for 4 variables, we're going to put all 4 in there. Okay? So here we go. Let me quickly take a picture. And these can be easy. As you can see, these are the lengthier ones. I rarely see this level of difficulty on there. It's mostly you get 3 equations and you're only looking for 3 variables. Getting this fourth equation, this is rare. That's why it was a little bit different when I first saw it. Nonetheless, here we go. Okay. So we're going to type all this into the calculator. Let's go menu 1.4 to clear, menu 1.5 to get a nice clear screen. Okay, and here we go. Menu 3, 7, 1. We're going to do 4 equations. And it will default those variables. You don't have to go and do these variables, okay? If you want to just do 4 equations, you can just press 4 equations and it will come up with the actual variables.
Thank you. Oh, I didn't see it over there.
So let's go A, comma B, comma B, comma C, comma D.
It's menu 1.7, right?
Menu 371. Okay, and if you get lost, no worries. I will text this to you, and you can practice this at home as well. Here we go. So the first equation is going to be, and get the practice with me if you can, 11a minus 13b minus c. You don't have to put anything because it's a 0d, but just push equals 0 or equals 8. Again, the equations that they gave me were 3a minus 7b. There's no c, so I could just put minus 4d is equal to a negative 9. Then I have 10a minus 6b minus 4c is equal to 7. And last but not least, I have a negative 2a plus 3c minus 4d is equal to 10. And it will give you all of those fractional pieces. Okay, so all your answers you just got. So I now know what A is equal to, I know what B is equal to, I know what C, and I know what D is equal to. So I can use these pieces right here that it gave me into that equation to satisfy, and it was like negative 10a minus 2b, and it said plus 2c. So all I need to do now is just plug this in, plug this c value in where c goes, plug this b value in where b goes, and plug this a value in where a goes, and then you'll just get your answer just like that. Okay, so let's do that just real quick together. So you have negative 10 times control divide 589 over 100. And then it's going to be minus 2 times, here's that b value, control divide 381 over 100. And then it'll be plus 2 times c, which is control divide 363 over 50. Okay? And then you will get negative 52, which is your answer. Cool? So it's definitely, to me, this is the beefiest that you'll see ever, as far as the calculator is concerned with these systems of equations. Okay, and if you need to, please practice by looking at the video at home.
Okay.
More than likely, you're going to see 3 variables with 3 equations, at most. But thank you for that question. That was a good question. Seriously, as you could see just now, that was the first time that I ever had encountered that. Okay? What else? From the homework that you had, any page, what else do you want to look at? Okay, so now we're looking at another calculator problem. We're looking at number 33 on page 194, and we're going to solve for one possible value of m. Okay? So our equation is all of this. Again, from last class I said look for the if, look for the comma, and pretty much solve for everything in between. Okay? So with me, we're going to go through. I'm going to show you how to effectively use this calculator that, of course, again, is allowed on the SAT. Alright, here we go. It almost feels like it shouldn't be just because of how easy it is to use, but a lot of people don't use it or learn it, and hence there's nothing wrong with it. So for current document, and here we go. Again, menu 1.5 will clear it so that you have a nice clear screen. Menu 1.5. And here we go. We want the calculator to do the work for us and solve this equation out. So we're going to start with menu, 3 for algebra, and 1 for solve. We want the calculator to solve this for us. And we're going to put negative 8, okay, is less than, and this is how you find less than, press control equals, and it's the second one right here. And just like it is on your paper, you're just going to type this out. Negative control divide 3 over 5 times m. Okay, and it's going to be plus 1 is control equals less than or equal to, it's that bottom middle one there, and then we're going to put negative control divide 16 over 5. Oops. And then you're going to tell the calculator what to do. So I didn't do it yet, that's why that error came up. Right here, when I finish it, I need to say, comma, look for the variable that I wanted it to solve for. What letter would I put here? M. Yep. And there it goes. So m is going to be between 7 and 5. And if you don't know this notation, here's 7 and 15, that is. 7 is closed, 15 is open, and it's everything in between, including 7. Okay? So you could...
Before you move on, I just wanted to make sure I can get this in my calculator myself.
Okay, go for it.
Hold on.
So 7 is the first one that you can put in there. You could also put 8, 9, 10, 11, 12, 13, all the way to 14. But because...
Why do you put comma?
On the bottom left. Because you have 15 there open, you're not going to include it, okay? So this one says, what is one possible value of m? It literally can be anything between 7, including 7 and 15. Okay, so over here, like on the answer, it would look something like this, because it's a griddable. So you could say, now you tell me, what number could you put between 7 and 15?
10.
You could put 10. So
What
if you
about
put,
10.5?
you could put 10.5. Let's say you put 10, you would do this and that. If you did 10.5, you could do the point, and the 5 would be there. Nice. All right, so now, what's your next question? Okay, so now on page 199, number 10, these are common for sure. When you see this word, I always tell my students, whenever they see this equivalent, you're basically trying to, of course, find out which one of these is the same, aka equivalent, as this. Now it's difficult for students to go from here to one of these case scenarios. It's a lot easier to try to pick one of these and say, can I make it look like my original asking problem? So I could pick C, I could pick D, I could pick any one of these, and my goal is, when I work it, is to simplify or alter what I have to become this. Okay? So which ones do y'all want to pick? It doesn't matter. We can start with any of them. Which one would you intuitively, and oh, here's another thing. When you read questions, you should always, always, always scan the answers first before you start working. Because 9 out of 10 times, if you don't scan, you're going to be doing a lot more work than you need to. Okay? So which one do y'all think we could start with? A, B, C, or D? A. So if we started with A, here we go. F of G is going to be distributed, because it's being multiplied with parentheses, with F plus G. That means these will be multiplied first. Oops, I like that. And if you multiply F over G times F, it's the same as over 1. This first term will give me F squared over G. Okay? Now if I do the same for the second term, I'm going to now have F over G, oops, is going to now multiply by a positive G. But again, this is over an understood 1. So you tell me right here, the way I see it, what have we learned right now in class right now when we see something like this? When I'm multiplying fractions.
Multiplication.
Not cross multiplication, but like cross simplification. Okay? So you have like G over G is a form of 1. So it will reduce to 1, just like if it was written like this. Okay? So that goes away per se, and all I'm left with is what? F. And sure enough, this looks exactly like that looked. So we did choose correctly, and the answer is what? A. Do you see how we're doing that? Okay. All right. Find another one. So on page 198, we're looking at 7. And yes, to me, when I see a lot of things to read, I immediately go to scan the answers. Okay? Because if I scan the answers, chances are I'm going to be able to go back and just scan the reading. Okay? So here we go. So I look at all the answers, and what I start to see are that some of them have inequality symbols, and some of them don't. Okay? So the next thing that I start to look at are the coefficients. So these are systems of equations, guys. These are two equations together in a parenthetic piece that they're a system of equations. And the fastest way that you can find these are, they're usually number of items and money. Okay? To where the money is like the amount of money, and the number of items is just like the total number. Okay? So now I can kind of go back and see what belongs with what. Okay? So let's go find X. So let's see, the density, you have grams, you have liters, you have X right here. X represents the number of liters of helium. Y represents the number of liters of nitrogen. Okay? And what does it say, numbers-wise, that that's going to be? Okay, so look, let me show you what I'm looking at. So numbers are usually full integer values. Okay? Whereas decimals are usually not associated with, like decimals belong with decimals per se.
They're real numbers.
Okay, yeah, they're all real numbers, right? So decimals and integers are still real numbers. But for the most part, what I'm saying is the integers usually belong with the total, okay? And then the amount is usually decimal because it's money. Okay? Now I know these aren't money. They're grams, but my point is that this is still decimal form and these are still integers. Do you see where I'm going with that? So x plus y, it says between these two gases, x and y, the balloon can be inflated up to. So there's your key word. So it can be up to 8. That shows it's either going to be equal to 8 or it can be less than 8. Does that make sense? So we know it's not going to be this one. We know it's not going to be this one. So it's either going to be C or D because you're going to be less than or equal to 8. Are we good? Okay. So now we start going for the decimal places. Okay, so you have X, and it says the density of nitrogen. So nitrogen, remember, is blue. That's 130. And then you have helium is 0.20. So the 0.20 belongs with the X, and the 1.3 belongs with the Y. You're with me? So the thing is that right now this looks very, very enticing to use. But the thing is that it has a little bit more to it. It says the balloon must be filled so that the volumetric average density of the balloon is lower than that of the air, which has the density of grams per liter. So basically, which of the following systems and equations best describes the balloon will be filled? So it's not just saying the grams per each one. This is more so talking about the density. Okay, so density, if you remember, density is like a certain mass over a volume. So you learned this in science, right? So the density is the mass over a volume, means that I need some kind of fractional piece at the bottom to measure the volume. So if I do x plus y, that's the total volume. You with me? It's not just over 1, because this is density. So it immediately tends and lends itself to that fractional piece. This is a system. I promise you will see systems. The ones that you mostly see are easier than this. They're more so just with dollars. These are as difficult as they get. So if you do have this volume of some kind, please gravitate more to this fractional piece of like over a total. Okay? But I hope that everything else is the same as far as how you strategize, and it makes it faster. And as you do more and more of these, you'll start immediately putting decimals with decimals, and you'll put the integrals or the integers with integers.
I have to ask, why do you stare at me when you start?
Oh, no, I'm just looking at everyone. I'm just looking at everyone.
Because like my eyes lock.
So, number 16 on page 204, it says, in the expression given, k is a negative integer. Which of the following is a possible value of k? So if I'm a negative integer, first of all, so that you know, natural numbers, you'll see this from time to time, naturally start at 1. Because if I told you to just start counting, you would naturally count from 1. Whole numbers, zeros included. And if I were to keep going with the negatives, so I have now -1, -2, and so on and so forth, this way, all of these are now integers. Okay? So when I'm looking at this, I have to know the difference between a natural number, a whole number, and then now integer. I'm looking at for k being negative. So I'm talking about like -1, -2, and so on and so forth. You with me? So we already know that that's not an answer. Okay? Does that make sense? Okay. So which of the following is a possible value of k? So if I'm looking at x squared plus kx plus 12, because of the fact that this is a trinomial and this is quadratic, chances are that I can go ahead and factor this. And if I factor that, I would get x and x, because they would be FOILed to give me this. And these numbers would multiply to give me the last number. So this is just factoring. Okay? What numbers could I put right there?
So we could use the box method.
Yep. What numbers would you put? 2 and 6? Yep. So 6 and 2. So right here, if this was positive, you see what I'm doing? I would get x squared. 6 and 2 give me 8. And then this would give me the positive 12. I have the positive 12 that I needed. I have the positive x squared that I needed. And now I would get a positive 8. But k is not a positive integer.
So you need to make both of the FOIL numbers into negatives.
Okay, so let's make those into negatives. Here we go. So this would be a negative negative, which still will give me this positive. But now I have a negative 8, which I don't see as one of my answers. So no worries, this is good trial and error. But instead of 2 and 6, we need to think of other factors that give me this 12. Okay, so what could they be?
What about negative 1 and
Yep.
positive 12?
Or negative 12 and a negative 1, right?
Yeah.
So you have x minus 12, x minus 1 to give you x squared, that's this one. Outside and inside for FOIL method gives you a negative 13x, and the last will give you that positive 12. And that's how negative 13 will be your answer. Alright, let's find another one. So number 12 on page 209 is very, very common. Very common. So you're dealing with quadratics, otherwise x squareds. And primarily this is dealing with factoring. So when you're dealing with quadratics, or really with anything, and you see the word solution, what it's really zeros,
or where the x-intercepts are.
x-intercepts, nice. So this is the same as solve for x. Okay, so here we go. Factoring, the first form of factoring is GCF. So if we pull out of everything and we divide by something that they all have in common, and this one, that would be what? 3. So it would be 3 parentheses, and then what's left is z squared minus 4z, right? And then plus what? 2. Perfect. So now I just factored the first step of factoring. It was GCF. So the second step now is I'm going to factor this trinomial into 2 binomials. So here we go. The first 2 terms will multiply to give me this term right here, which is z squared. Okay, so that's those 2. The last 2 terms will multiply to give me 2. Then I have to figure out, do they add from what I chose, do they add up the inside and the outside to this center value of negative 4? So the z's, that's the easy part. Okay, so 2's, if I put 2 and 1, because I know they will multiply to give me 2, watch what I have. Let me make this a little clearer. This is a z, and that's a z. So I have 2, I have 1, I got 3. That's not 4. Okay? So whenever I run into this, there's no other factors of 2. It's either 1 or 2, and that's it. Okay? So if you run into this, you have to do the quadratic formula. Okay, but before that, I do a lot of tutoring. We've already spoken about the discriminant test? Okay, so we have not. Okay, here we go. The discriminant test will help you reduce the amount of work that you do. A lot of people dismiss it, but it is so, so important, especially of how the testers test these questions. They revolve it around b squared minus 4ac. So from this original thing, you can even do it. A is 3, B is negative 12, and C is 6. And if I did b squared minus 4ac, I have right here a positive 144. And I'm subtracting whatever that is, which is 12 and 6 gives you 72. My point is, this is going to give me a positive answer. If it's a positive answer, I should be able to find two solutions, or two x-intercepts, or two zeros. Okay, because the graph will look like something where it crosses the x-axis twice. If this was a negative, it would never cross the x-axis. And you'd need two imaginary roots, otherwise no solutions. Okay? And if it hit the graph only one time, meaning it equaled 0, so you only have three choices, positive, negative, or 0 from this discriminant test. Then it would hit the x-axis only at one point, and you'd have one answer. So this gave us a positive, says that means we need two answers. We know it's not factorable, so that I do have to go ahead and do the quadratic formula. Okay? These are not common, and the ones that you guys are picking are really, really good problems, because they're like the ones that when all other things exhaust and it all fails, that's what you were supposed to have done. But what I'm trying to stress with this problem is to use the discriminant test, because the faster you know it, the faster you can go to that long process that you have to do to get the answer. Okay? So you could do it from the original one, guys, or you can do it from the reduced one. I think the reduced one is a lot faster. So here we go. The quadratic formula is negative b, which is a negative 4. Okay? Then it's plus or minus the square root of b squared. This parentheses is super important. A lot of people put that negative on the outside and it gives them a different answer. And then minus 4ac. So 4a was 1, c was 2 on the most reduced form. All over 2a. Are we good?
How would we put that in the calculator?
So this one's not a calculator one, I don't think. I think this is, if it is a calculator, it will have a calculator right next to it. So this is by hand. Okay?
Oh.
So from this we have...
What I mean is, how would I put plus or minus in the equation? Or in the calculator?
It's not a calculator problem.
I mean, if I get a problem like that and it is on a calculator, how would I put just the plus or minus in the calculator?
You just do two of them. You'll do the plus one, and then you'll write the whole thing with a minus one. Okay?
Oh, okay, that makes more sense.
But here's the thing. If you did it with the calculator, you wouldn't do it this long way. You would do it the way I showed you before with the other ones of menu 3.1, the solve feature. It will solve it out for you. You don't have to do this long way with the calculator. Okay? So here we go. So 16, we have negative 4, 1, and 2 gives me a negative 8. We have a positive 4.
Sir, I will be leaving at 55.
That's
or
okay.
50.
Okay.
I'll start packing up at 50, and then at 53, if that's when you finish that particular question.
Okay.
Pretty much from here on out, I'll be leaving.
Okay, that's
after
okay.
you finish the last question on
Okay.
around 50.
So 16 minus 8, guys, will give us 8. It is still underneath the square root, and this is my running answer as of right now. Okay, so now all we have to do is just simplify this 4 plus or minus square root of 8 over 2. The thing that they want you to learn from here is going to be this piece right here. I need to simplify root 8. Okay? So, root 8, can I pull square root of 8 out?
No.
No. So I need to break this up into factors that I can pull something out, which in this case is this 4. So this will come out as 2 root 2, and then all of this other stuff is still left. 4 plus or minus all over 2. Okay? And from this is two equations. Okay, so this is the plus version. It is a lot, and it's the minus version. So the way we break this up is 4 plus or minus 2 root 2 over 2. Okay, so in 5th grade, way back when we did this, 1/3 plus 5/3. We easily got 1 plus 5 all over 3. What we're doing is we're just going backwards with this. We're breaking it up into two fractions when it's all over one term. What does this reduce to? 2. And then this reduces, right? The coefficient reduces, not the inside of the square root. It's like saying 2x over 2. Just that piece reduces. So you'd be left with what? Square root of 2. So you have a 2 plus root 2, and you have a 2 minus root 2. Both of those are your answers, okay? I know, you guys chose the more difficult, and that's okay. The ones that you are choosing are the most difficult ones. And if you can get this in the 5 weeks that we're together, all the easier ones you're going to do just fine, okay? So what does product mean?
What is the, pretty much, multiply.
Multiply. Here we go. So
I'm sorry, that took me a couple of seconds to say, I'm sorry.
You're good, you're good. So 2 plus root 2 times 2 minus root 2. If I multiply these, I get 4. Outside and inside, look what I have. I have 2 root 2, that is a negative, and then I have a 2 root 2, that's a positive. What do those become? 0.
0.
So then you have the last one, which is a positive times a negative. Oops. So a positive times a negative will give you a negative. And then it's going to be root 2 times root 2, which is root 2 squared, is what? Just 2. So it's 4 minus 2. All of that becomes just 4 minus 2, which the answer is 2. Okay? These are the heftier ones. They are by hand, but remember, SAT, unlike ACT, you have non-calculator portions, and that's the one that most people struggle with. This is
So
hence.
should we just, if we come across this early, should we just skip it, do the other easy?
All right, so here we go. 13 on page 212. This is huge. Usually it's memorized, but they gave it to you. Real quick, another thing that you should memorize is that if I is square root of negative 1, what do you think I squared would be? Not 1, but just negative 1. Yep. And I know it's weird, but this is the only thing that when you square it, it doesn't automatically make it a positive. So this is dealing with imaginary numbers. And imaginary numbers, really, for all testing purposes, it just means this. These two facts are memorized, and then they're manipulated, and they're used in the expressions that you're given. Okay? So if I have this, what I hope that you recognize is I have a square root in the denominator. And normally what we're taught, and this is on your Delta Math homework, guys, in the math, the homework is extensive. I promise you. This is the most important chapter that you'll take all this 5 weeks. So please don't blow off the homework, okay? Do as much of that as possible that you can do. Right here, rationalizing the denominator, let's say I have something that looked like that. Totally new problem. When the square root is not allowed in the denominator, the way we get rid of it is we multiply by that same thing, but a form of 1 of it. Because you can't multiply anything just by whatever you want. You can if there's an equal sign. You could do 3 on the left, 3 on the right. But if there's no equal sign, you can only multiply by forms of 1. Because now, look what happens on the denominator. That's 2. Whoops. And the top becomes 6 root 2. So the square root's gone. That was the goal. And now I can reduce this to 3 root 2. So my original thing of 6 root 2 became that with no square root in the denominator. Okay? And I'm about to do that with this, but it's a little bit more extensive. Okay? But the same idea. So, real quick. X minus 3, x plus 3. If I FOIL this out, what does it become? X squared minus 9. Perfect. Because what happens to those two? They become 0. They zero out when you combine like terms. If you didn't know this already, this is called a difference of squares. You with me? Squares, if I took this and squared it, I get x squared. If I took this and squared it, I get 9. You with me? So a difference of squares means that I could square root each of these, which the first one would become x, and square root 9, which that one would become 3. And because this is a subtraction, this must be a positive and that must be a negative. That's how you factor a difference of squares. You with me? The reason why I showed you that is because that would become 0. Over here, we're wanting to do the same exact thing. We want to make the square root in the denominator go away, but also make sure we don't create any of these middle terms that are going to exist right here. Okay? So the form of 1 is this one right here. It's the same thing as the denominator. The only difference is now I have a positive and a negative. You with me? This will do exactly what this one did. There's no inside or outside term because they cancel to 0. So all we're going to be left with is the first and the last. Okay, so let's go ahead and fold this out. So when I multiply just the denominators together, what do the 2's become? 4. What do the square roots of 10i become? Nope. So okay, I'm sorry. You were thinking about this. That becomes 0. But then what do the last terms, like over here, what will these last terms become when I multiply them? It would just become 10i. And because this is a negative and this is a positive, there's a subtraction. You see how the square root just lifted up? Because there's 2 of them. Okay? Just like whenever I said root 2 times root 2, it just lifts up and becomes 2. Okay? And now the top has all, not just I. Actually, it is just I, my bad. So I'm left with 4 minus 10i. Any questions so far? Alright, so now let's go ahead and finish it off. I'm going to move on to the top. The top is going to be distributed. So I get 28 plus 14 root 10i. And from here, I can do it one more time. So 4 plus 10i and 4 plus 10i. So here we go. This bottom piece will become 16 because that's the 4's, combined together. The 10i and 10i will become 100i squared. The negative and positive become a negative. And remember how I told you over here that I squared is the same as negative 1. So this is the same as if you were putting 16 minus a negative 100. So it's a positive 116 on the bottom. And maybe I might have done this the more confusing way. Remember, no worries. Remember how I said it's probably easier to make these look like that when you have the word equivalent? Looking in retrospect, that's probably the easiest way that we could have done this. No worries. That's the first time that I went the wrong way. But we saw what I was doing, right? Okay. So the reason why I do this is because it's called the conjugate. We do use that method on easier ones of this. Okay, so you wouldn't necessarily try to go from the expression to your original. you would use the conjugate. Do we understand though? Okay? I'm going to leave that for now only because we're out of time. But are there any other questions before we leave in general? So what's your homework? The delta map, okay? Finish this chapter 12 if you need to, if you didn't finish it completely, but please, only one person has 17% of that delta map done right now. Everyone's at 0. Please, please, please make sure that you have the delta map done by Sunday night. And I will see you guys on Monday.